Yeah, but let's get started straight away. Maps and plans. All right, here we go. So this is obviously a plan, not a map. Let's read the contextual paragraph here. It says, your younger little sister Lisa is going to grade 1 next year. Lisa is afraid of getting lost around her new school. She likes to know exactly where she needs to go at all times, or else she tends to panic and cry. As she is going to your old primary school, you are able to help make getting around the school easier for her. You draw a sketch of the school as shown below. Well done, guys. You've drawn an incredible sketch. Hey, Kian. There's your sketch of the school. Oh, no, come on now. Oh, she wants to get stuck. Oh, yeah. There we go. All right. There's your sketch of the school. Well done. Very good drawing. Okay. Looking at the sketch, obviously, we have these rectangular blocks as classrooms. Okay. And obviously, these little tiny rectangular blocks are windows. All right. Often in plan drawings, those are windows. And this quarter circle shape is obviously the door. Those are often shown in plans as doors. And this is the layout of the school. So we've got all kinds of rooms here with teachers' classrooms. We've got the principal's office. We've got the secretary's office, girls' toilet, boys' toilet, the school hall, fields over here, and a whole lot of teachers' classrooms surrounding a grass patch in the middle. Okay. All right. Let's have a look. Question number 1. All learners will enter the school through the front door on the first day. No learners allowed on the grass except at break time under supervision of a teacher. So the front door is over here on the right-hand side. So 1.1 says, your sister's going to grade 1. On which side of the school is Lisa's class, your sister? Use a compass direction for your answer. On which side of the school is your sister's class? Use a compass direction for your answer. Everyone should be able to get this. Where is Lisa grade 1, her class? Where is her class going to be situated? Which side of the school? Southeast is down here. But Lisa is in grade 1. So it must be one of these two classrooms here. So we've got grade 1A and 1B there. So which side of the school are her classrooms? North, northwest. Yeah, so the question is, where do we put our compass? Because we've got to have a compass somewhere. Now, we're not going to put it, it's not saying what direction from the front of the school. It's just saying which side of the school. So we can actually put this compass in the middle, all right, with the north facing this way. So I would say north or northwest, right? It's either there or it's going straight up, which is north. North or northwest would be correct here, I think. Yeah, north or northwest. So the compass is going to be in the middle of the school. Then I would say north or northwest is correct. Definitely. Okay. Very easy. Very, very, very easy. Northwest part of the school. All right. Yes. Okay, let's have a look at the next question. So this one was northwest. Lisa is going into Miss Smith's class next year. Give her directions how to get from the front door of the school to Miss Smith's classroom. All right, so she's coming, they say every grade 1 has to come in the front entrance. And obviously there is a door over here between the principal's office and the secretary's office. All right, so we're going to give her directions. Guys, girls, who would like to help give directions? Anybody?
Somebody.
Somebody?
Anybody.
Anybody?
And you know what, guys? You need to indulge us tonight because one, we are like a very small class, and
Yeah.
two, it's the final lesson.
Yeah, someone new. Someone new. I mean, someone whose voice we haven't heard. I haven't heard Atia's voice. Isivile, I haven't heard voice from Isivile. Wantle. Tato, I think I've heard before. Zahir, I think I've heard before. Viwe, I think I've heard before. Let's ask Atia. Atia, are you there? Atia, are you there? Check your screen. Talk to us, Atia. Atia?
Hi, sir.
Hey, how are you?
Fine, and you?
Good. Are your exams finished?
No, I have one more.
Which one?
Tourism.
You finished your math lit exams.
Yes,
And how did they go?
they were okay.
All right. You feel confident.
Yeah, my
Good.
first paper went well. My second, it was okay.
All right. Which topic in math literacy did you find the hardest in those papers?
Um, I think it's more like the measurement part.
Yeah, often the case.
Yeah.
Measurements often the case. All right. Well, help us out one last time here tonight. We need to give this young grade one learner directions to get to her class. Lisa, she has to go through the front of the school to get to Miss Smith. Miss Smith is over there, class 1B. How would you give her directions to get to Miss Smith's class?
Um, okay, so she would walk through the front door between the principal's office and the secretary's office,
Yep,
and then she would turn right
yep,
and then left, and then on her right she will pass the grade 4 and grade 3 class,
good.
and then um she will turn right again and she will be by her class.
All right, good. Excellent. Turn right to class to grade 1B, which is Miss Smith's class. Perfect. Atia, that was absolutely perfect. I'm sure you did very well in your exams.
Thank you.
All right, good to hear your voice. Thank you, Atia. All right, that's it.
Thank you.
So we're using directions like left and right, and also please remember to always refer to things that you're going past. So go through the front office, past the principal's, between the principal's office and the secretary's office, turn right as soon as you come through that corridor, stay on the veranda, walk towards the grade 4 class, turn left when you see the door of the grade 4 class, stay on the veranda, go past Miss Faith or grade 3B. It's the classroom after grade 3B, which is 1B. All right, very good. Very, very good. Well done. Okay, I'm not going to write all that down, but you guys get the idea. Okay. They often ask that direction question when it comes to maps and plans. Okay, here's the next question. Is there a single or double door going out to the playing fields? Why do you think this is so? Is there a single or double door going out to the playing fields? All right, so where is this door? So here are the playing fields here. The only door I can see is this one here. All right, and it looks like a double door. Why do you think they'll put a double door there? No calculations here. It's just your subjective answer. What you think. Why do you guys think they put a double door there to the playing fields? Anybody? You can raise your hand. Catlejo. There we go. Check your screen.
Hello, sir.
Hey, how are you?
I'm good and you, sir?
Good. You finished your exams? Oh,
No,
you
sir,
said
I'm
you're
writing
writing.
math.
You're
Yeah,
writing,
I'm
yes.
writing math paper 1 and on Monday paper 2.
Are you feeling confident?
Yes, sir.
Excellent. Good. Very good. Why do you think they put double doors there?
I think it's for exit and for the entry.
Yeah. So why do you think they put two doors and not just one?
I think that learners, maybe they shouldn't clutch each other while running after break or after playing.
Yeah, they need very good. They need that space for when they exit the school and enter the school there, because everyone's going to break at the same time, obviously. There's only one exit,
Yes.
only one exit to the playing fields. It's only one. So all the schools going there, and they need the space to get through that door there. Very good.
Yes.
Perfect. Perfect,
Thank you,
Atliho. Thank
sir.
you. Thank you so much. All right. Excellent. Let's move on to the next one. Question number 2. Here we go. Lisa wants to know how big her grade 1 classroom is. Measure the length and breadth of a classroom on the drawing. Give your answer in centimeters. Now, obviously, you can't measure this. I've done it for you. So I've given measurements here. And obviously, these measurements are with a ruler. So when they say measure, you're using a ruler here. Whoopsie. I did not measure. I promise you I didn't measure meters. I measured in centimeters. There we go. All right. So I measured 4.5 centimeters for the length and 2 centimeters for the breadth. So if I go up to the drawing here, I can show you that the length of this classroom is 4.5, and the breadth of the classroom or width of the classroom, same thing, is 2 centimeters. That's what I measured for you guys. Okay. All right. What do we need to do? So we've answered that question already. I've done it for you. Here comes the next one. 2.2. Using the scale provided, give the real life length and breadth of the classroom. Now, okay, the scale was there, but now it's disappeared. So I'm going to tell you that the scale is 1 is to 150. 1 is to 150. Okay, let me bring that down. So this is the scale here. 1 is to 150. We need to use this scale and our measurements to work out the real life length and breadth of a classroom. Who can help me with this one? Who haven't we heard before? Isavile? Isabella Shumane, are you there? Check your screen. There's a little icon to ask if you can unmute. Do you want to talk to us and help us out with this question? Isabella, you there? Check your screen, Isabella. Talk to us, please.
Everybody's getting a chance tonight.
Everyone, let's try Lwandle. Lwandle, check your screen there.
Remember, it's not Netflix and chill.
Yeah, you guys have got to be active participants. Lwandle, come on, check your screen. I know you're there. Lwandle? Lwandle's not there. Sianda. Sianda Shange, are you there? Check your screen, Sianda Shange. Come in, Sianda, are you there? Crickets. These guys log on and then watch Netflix. All right. Kayan's put some figures up there, which is absolutely perfect. So for the length, let's do the length first. We're going to take our ruler measurement of 4.5 centimeters. And for every one, so there's the scale that we have here, this is ruler on the left, and this is real world on the right. So if we want a real world figure, we're going to take the ruler one and convert it by multiplying by 150. So 1 centimeter is 150. We got 4.5 centimeters. We're going to multiply by 150. And like Kayan showed, we're just going to multiply quickly. That's 600. But what are the units? Kayan, what units you got there for 600? 600 what? $4.5. I've got it wrong. It's 4.5, sorry. 4.5 times 1 is 675. 675 and 300. The units are okay, so if you read the scale, I'll write it in blue. The scale, this ratio here, 1 is to 150. Every ratio scale has the same units on the left and the right. Otherwise, it won't work. So 1 centimeter on my ruler represents 150 centimeters in the real world. So I'm timesing by 150 and I'm getting centimeters as my final answer here. Okay. So we got centimeters here. Now, the question didn't say give your answer in meters or kilometers or anything. It just said give the real life length. So these answers here are acceptable. All right. But let's say we wanted to convert these into meters. All right. Because how do you measure a classroom if not in meters? So let's convert these into meters. How do we do that? What do we do to our 675 centimeters to get to meters? You all know. How many centimeters in a meter? Yes, 100. So we're going to divide by 100 here. All right. And we're going to get 6,75 meters and divide by 100 and we get 3 meters. All right. So if we want meters, if they want meters, we can convert to meters. All right. The classroom dimensions are usually in meters. So this is why we're trying it now. But the previous answer of 675 and 300 is perfectly acceptable. They didn't give instructions on what units to use, so that's fine. All right, so easy to use a scale to get real world dimensions. Okay, let's move on to something a little bit different now. Here we have a road map of an American region called Rochester. Okay, so this is a part of Canada? No, it's America. It's Rochester in America. It just says Canada on the top left there. It's obviously near the border. All right, so this is Rochester in America. And this map is showing us national routes. Okay? And you can see here by these icons. Why am I using red when everything else is in red? Let's use green. You can see here by these funny shields, these are the road names. So in America, it's Route 91 or Route 87 or Road 91 or Road 87. Okay. So those are the route numbers for this map. All right, and then we also see here at the bottom, they've given us a line scale to use. They've given us a line scale to use. Excuse me. All right, let's see what questions they have for this map. Question number 1. Write down the name of the city where roads 84, 91, and 95 meet. 84, 91, and 95. 84, 91, and 95. Write down the name of the city where they meet. Can anyone see it? Route 84, 91, and 95 all meet at a city. Here's a clue. There's a saying, all roads lead to Rome. Well, this is not Italy. This is not Italy. This is America. So all roads lead to, yes, Kayan, New York at the bottom there. Okay, so if I draw with green, we've got 91 coming down here. 84 is over here. And 95 is over here. And they all come down to New York City. All right, one of the biggest cities in America, if not the biggest city in America. Okay, so all three of those routes combine at New York City. So the answer for that question is New York City. Not even any just some calculations for scale, but it's not hardly any calculations in this section, eh? All right, question number 2. Using the given scale, determine the actual distance. Now here's instead of real, they say actual, but these mean the same thing. Real or actual distance in miles, we don't really use miles, but we're going to today, between Buffalo and Albany. If the distance on the map between these two places is 7.5 centimeters. Now, Buffalo and Albany. Let's just first find these places. Okay. Albany is, let me use green. Albany is here. Hope you guys can see that. And Buffalo is here on the left. All right, maybe those colors aren't the best. Let's use yellow. So Albany is here and Buffalo is there. Now I've got to give you that 7.5. So right. So on the line scale at the bottom here, you need if you get given this map and you are told to use this scale, you've got to take your ruler and actually measure this line here at the bottom, right? And what you do is you just measure this first section there, because you know that piece is 50 miles, or if you want to, you can use the whole thing, it's 100, but usually we want to measure this first section here. Okay. Now I have done it for you, and I'm telling you that this whole piece here, I'm going to use green again. This whole piece that I'm highlighting in green is 2 centimeters. You measured it with your ruler and it measured 2 centimeters. And we need to measure the straight line distance. All right, we're going to do a straight line distance. So I'm going to draw a green line here between these two places, Buffalo and Albany. That is 7.5 centimeters in a straight line. Our line scale, that first segment, which is 50 miles, is 2 centimeters. How are we going to get the real distance of this green line here? Anyone have an idea? Is there anybody?
Remember, it's too hot for it to be crickets tonight. Yes.
Ah,
Not fair.
hey.
Hey, sir.
Wande, how are you?
I'm good. Thanks in yourself, sir.
I'm good. How are your exams?
Sir, I finished last week Friday, so I've been relaxing the whole week.
Oh my word.
I've been on my break.
We are so jealous.
I know,
But
sir.
are you feeling good that you're
Yes,
relaxing
sir,
now?
I am.
How did the
Very much.
how did the math literacy exams go?
Sir, the measurement ish.
Yeah,
It kind of humbled me, but I tried.
that's fine. That's fine. The measurement is the hard section. They can come up with some really difficult questions there, but you just got to
Yes.
practice. Just got to practice that a little bit more.
Yes, sir.
Okay. What do we do here? So we've measured the line scale. That 50-mile section is 2 centimeters. Our green line, the big green line from Buffalo to Albany, is 7.5 centimeters. What do we do?
Sir, can I try?
Yeah.
I'm trying.
Mm.
So, sir, I think you're gonna say 7.5 times 2 centimeter.
Okay. So, okay.
And then
Yeah.
you're gonna get 15.
Yeah. And then what
And
you
then
gonna do with it?
are you gonna times that 15 with the 50?
You should do that at the end. Yes, you must times by the 50. Okay. Now your first part, when you say you're going to times by 2, what you're trying to do is to work out how many of these little green sections at the bottom here, how many are there in that long green piece? I want to know how many little green pieces can fit in that long green piece. So how do we do that mathematically? I've got 7.5 centimeters. I want to know how many 2 centimeter pieces we can fit in there.
So sir, don't I say 7.5 times 50?
In the end, you will times 50. But first, to find out how many small pieces are in that 7.5. If I say to you, what analogy can I use? Let's say you've got a can of Coke, right? And it's 200 milliliters of Coke. And someone says to you, every time you take a sip of Coke, it's 50 milliliters of Coke. How many sips can you take? So what would you do then? You got a 200 milliliter Coke can, Every sip is 50 milliliters. How are you going to work out how many sips you can take?
So don't I divide?
Yes.
So I'm gonna say 7.5 divided by 2 centimeters times 50.
Yes. On the money. All right. So we've got a 7.5 centimeter piece. We want to know how many of these 2 centimeter pieces we have. All right. Let's get
7.5 times 2 is equals 3.75. Then I say times 50, which is gonna give me 187.5.
Yes. That's exactly it.
Thank you, sir.
Thank you. That was fantastic. 187.5. And what are the units? We're working with miles. Okay, so this linear scale is working with miles. Wadley, thank you so much for the help. That was fantastic. Okay, so we're cutting the big green line up and to see how many of these little green sections we have. All right, so there's our big green line. We want to know how many of these little green pieces we can fit on that line, because each one is 50 miles. So we're going to cut the big one up, divide 7.5 centimeters by 2 centimeters. We found there was 3 3/4 of these that we can fit in there, and then each one is 50 miles, so you times by 50. All right. Yes, it's lit. It's math lit. All right, number 3. Identify the roads that Bande will use to travel from Scranton to Albany. From Scranton to Albany. Now we know where Albany is. So Albany is this little white dot over there that I've highlighted in green. Scranton is down here. Identify the roads that someone will take to go from Scranton to Albany. From Scranton to Albany, what roads must you take? Who can help me? Who can help me? Let's see. Sianda, you there? We're still waiting for Sianda. 848188. Eight four eight one eight eight. All right, so you guys are saying 84. There's the 8481. Now, if we go from Scranton on the 84, guys and girls, if we go from Scranton this way on the 84, we're going to have to turn up north to get to Albany onto the what? From the 84, I'm happy to start on the 84. If we go down here on the 84, we're going to have to turn up on the, yes, the 87. We're going to turn north on the 87 all the way to Albany. That seems to be the quickest route. I'd say that's probably the best one. So we're going to take the 84 until we turn north on the 87 all the way to Albany. All right, so how would you write that? Yes, the 84 and the 87. So let's just read the question again to make sure we get it. Identify the road. So they're using the word identify. So they're not saying describe a route. They're just saying identify the roads. So we'll say road 84 and 87. That's it. We've identified them. Someone says to you, can you identify the person that did this to you? You either point them out or you say their name, all right? So we name the roads. So identifying is just naming the roads. So we just named the roads that we're going to use. Now you could use, whoopsie, sorry guys. You could use another route if you want. So this is not the only correct answer. We can also go 8188, and then we'll join the 90 for the last little section to Albany. So we can go that way as well. All right, there are other options. That one that you guys suggested is not the only option. So there are other options here to get your 2 marks. Okay. All right. Number 4, let's have a look and see. Write down the compass direction when traveling from Hartford to Boston. Write down the compass direction from Hartford to Boston. All right, so let's just find Hartford and Boston first. So here's Hartford. I've highlighted there with green. Hartford. And we are going to Boston over there. Now, what is the key word in this question that we need to find? What's the most important word in this question here? Number 4, write down the compass direction when traveling from Hartford to Boston. Which word is the most important one in here? Luandle, before you say southeast, first tell me which word is the most important one when we're talking about direction. Which word? Okay, compass, yes, compass directions. We need to use compass directions, good. But what other word are we looking for when we have this kind of question? What word is important to note? And I've told you guys this before. Always remember when you're going from one point to another, always put your compass on the place you're going. Because we have to put our compass somewhere. Which town do we put our compass on? There's a word that that tells you in this sentence. Can anyone remember? Yes, you know it's Hartford. Why? Because this word. Yes. Okay, on. There we go. From. That is the key. From Hartford. So the word from in front of that place means we've got to put our compass on the Hartford. Okay. So you look for the word from. We're going from Hartford, so we're going to put our compass point on Hartford, and I want to try and use let's use blue. From Hartford. Okay, so we're going to put our blue compass from Hartford. All right, so in the exam, you draw your compass on that one there, or you can even do it in your head, it's fine. And then we're going to go from Hartford. Whoopsie, that's a square. I need an arrow. We're going from Hartford to Boston. To Boston. Okay. Now you can tell me what is that direction. Yes, Atia. Northeast. Okay, so I'll draw the little compass on the side here. And we're going in that direction like that. That is northeast. Okay. So please, the key word when you have a direction question is the word from. All right, the word from. Okay, so look for the word from. That's where you're going to put your compass. Will you guys remember that? I hope you all remember that. All right. Question number 5. Identify the road that will help you to travel from New York to the far west of the map. From New York to the far west of the map, which road should you be taking? From New York to the far west of the map. Remember, New York was the big city down here. Which road will take you to the far west of the map? Yes, Tato, on the money. The 80. Okay, so this long road here goes all the way to the far west. Okay. Absolutely, Tato. Well done. Yep. The 80. Very good. All right. Let's have a look at the next one. What? Guys, I told you they would do this. They're going to do it to you. For those of you that haven't written yet, expect it. They've injected a probability question in here. All right, the probability questions are not usually in their own section. They're always injected into the other topics. So this is why we're doing one here tonight. Expect for a probability question to pop up. It probably will happen. All right, there's a very good chance it will happen. So determine the probability. Now we know with probability, we need a fraction. All right, with something at the top, something at the bottom. The number at the bottom is the total possible. All the possibilities. All the possibilities. Okay. And then the number at the top is our query. All right. For this question. Okay. So we need to find the total possible first, and then we can find the number at the top afterwards. So the probability of randomly selecting a road on the map with an even number. Oh my gosh. Sure, guys, a road on the map with even number. Let's look at the white ones only. Okay, so I'm going to quickly circle all the ones that have an even. First of all, we've got to count them all, right? So we've got 1, we've got 89, we've got 91 covered. In fact, what I'm going to do is highlight this. Oopsie. I'm going to highlight the ones and make sure that we've covered them. Okay, so we've got 91, we've got 93. All right, we've got 89 done. We've got 95 done. We've got the 90 done. You guys must count as we go. How many numbers have we done so far? 91, 93, 89, 95, 90. That's 1, 2, 3, 4, 5. Here's the 84, which is the 6th one. Here's the 81, which is the 7th one. Here's the 17, which is the 8th one. Here's the 90, which is the 9th one. Here's the 79, which is 10th. Here's the 86, which is the 11th. Here's the 80, which is the 12th. The 87th is the 13th one. The 395 is the 14th. The 380 is the 15th. I've got a 78 at the bottom, which is what's that now? The 16th. 495 is 17, sorry, 17, 18, 19, 20. So we've got, oh, and the 390, 21. So let's say we've got 21 roads on the map, okay? 21 possible options here. So that goes at the bottom of our fraction, right? There's a possible 21 total possible. They want the ones that are even. So we've got to find all the even ones. So what I'm going to do is I'm going to quickly get
Mr.
rid of all.
Dale,
Yes, ma'am.
you might have skipped 88. So it's going to be 22.
22.
or 12.
Perfect. Let's make it 22. Let's make it 22. All right. I hope they don't give you something like this in your exam. It takes a while to count these. There's 22, and we want the even ones, right? So let's color in the even ones. 90, that's 1. 84 is 2. The 80 is 3. 90 on the left, we've done that already, hey? The 390 is 4. The 380 is 5. The 88 is 6. The 86 is 7. The 90 we've done.
76 at the bottom.
76 on the left is, what's that? 9? 8?
9, I think.
9. And 78 is 10. All right, so there are 10 even numbers. So there's 10 out of a possible 22. All right. You guys see that? So always a fraction. At the bottom of the fraction, all the possible options you can have. At the top of the fractions, the query that the question is specifically referring to. And then sometimes I ask you to show this probability either as a decimal or percentage. If you want to write it as a decimal, okay, if they say show it as a decimal to 2 decimal places, we just get our fraction out and we put it in there. Underneath, we put 22 and 0.45. So 0.45. Sometimes they say show it as a percentage. We'll take our decimal and times it by 100. And that's obviously 45.45%. Sometimes they say show it as a fraction in simplified form. All right, if they want that, I don't know why they would want that, but if they do, we just take our fraction and we press equals on a calculator and we get 5/11. Okay, so they could ask for many different options. Are we all good with that? All good with that? Speak now, do not hold your peace. Are we all good? Yeah. Are we good, ladies and gents? All right, can we move on to the next one here? I've got a really good one at the end. A really, really good one at the end. Okay, here we go. A certain winner was selected randomly, and this Mr. Sokutu won the grand prize of 150,000 Rand in a competition. He submitted 1,000 entries out of a total of 10,000 possible entries in this competition. He decided to use 90,000 Rand from the 150,000 Rand to extend his single garage into a double garage. He had a draftsman, which is a man that draws up maps, excuse me, to draw the plan below. So what we see here is his existing garage there on the right and his new planned section that he's going to build. All right, so obviously he's extending. You see the word here, extend, means to take what was originally there and make bigger. So eventually this whole rectangle will be his garage. That's what he's going to do with the prize money. So this is a plan of that. And here at the bottom, again, we see a scale of a 1:150. All right, let's check out the questions. Number 1, calculate the actual length and breadth of the existing and planned new garage in meters using the given scale. You measured, whoa, careful guys. You measured these measurements. They want to know what is the real measurement in meters. Okay, who can help me with this one? We've tried it before. Come on, I know you guys can do this. Is someone out there? Wandle.
Hi again, sir.
Hi again, Wandle. All right, what do we do?
So, sir, you're gonna take your length and times it by the 150 from the scale.
All right, so 50,4 millimeters times by 150. All right, 7560. But what are these units?
In millimeters, sir.
Yes, excellent. All right. Let me do the breadth or the width, sorry, just underneath here. We're going to do the same thing, eh?
Yes, sir.
All right.
Ye-
25.6 times 150, 3840. 3840 millimeters. All right. Am I done?
Yes, sir.
Let's check the question
No.
again. Calculate
No.
calculate the actual length and breadth of the existing and planned new garage in meters. So we've
So
got
you need to convert.
Yes. How do we change millimeters into meters? How many millimeters are there in a meter?
So they are. Ooh,
How many centimeters are there in a meter? Do you know?
100, sir.
Good. How many millimeters are there in a meter?
So it's a 10.
It's much more. Not much more.
1,000.
Yes, it's more. All right. There's 100 centimeters in a meter, but there are 1,000 millimeters in a meter. So we must divide this by 1,000, and we'll get 1,756 meters. And we'll do the same with the bottom. 3840 divide by 1,000 equals 3,840 meters. Okay. Are we done? We converted it to meters, but I think I want to round off. Hey, we should always round off.
Yes, sir.
So what will
To
the
the
top one be?
decimal.
Yeah, so what will the top one be? One, we're looking at this 5. Will it change? Will the number behind it make a change?
Yes, sir.
It will. So it's gonna be 1,7
6.
6 meters. All right. And then the bottom one is going to be 3,8. Will the 4 change? No, that 0 behind it won't make a change. So there we go, 3,84. All right. Calculate the actual length and breadth. That's what we've done. Then 100 in meters. That's what we've done. Windley, as usual. Very good. Thank you so much. Excellent job. Yeah, Windley's on fire tonight. Very good. And it's not just the heat. It's lit. All right. 2.2, let's have a look. Calculate the floor space he will now have available in his new double garage. Give your answer to the nearest square meter. Use the formula area of a rectangle equals length times breadth. So we've got to use this formula. They want the units in square meters, which is good for us because we've got our length and breadth now in meters. So all I'm going to do is take these from the previous answer and I'm going to use those. So I think this was the length. No, that's not the length. That is the breadth. I've mixed the letters up there. Hold on. Guys, we made a mistake. Did you see that? Our length is supposed to be longer. We got 7560 at the top here. And it changed to a 1756. That's my mistake. 7560. You see, all of a sudden our length became smaller than our breadth, which is not supposed to happen. So this needs to change to 7,560 meters, which is 7,56. There we go. That's better. Our length is supposed to be longer than our breadth. All right, there we go. This is better. Whoopsie. Let's put it over here. And our breadth is 3,84. We need to multiply these two values together. And what do we get? All right, Keon, as usual, fast with the fingers. On this calculator button, 3.84 times 7.56 is 29,0304. Yes, 29. Well done, Tano. 29,0304. 29,0304 meters squared. Because we're working in meters now. Meters times meters gives us meters squared. Okay, and we round this off to 29,03 meters squared. So that is the area of the garage. This new garage she's going to have. Okay. Not too bad. Not too bad. Oh, look again here. Look what they've done again. Yes, golden rule, never forget your units. Determine the probability. You see, they inject this kind of question all over the place. Again, with a probability question. So the probability, we need a fraction. We need the total possible at the bottom and the query at the top. So let's read it. Determine the probability that Mr. Sakutu of not winning the competition taking into account the number of entries he submitted. Give your answer in percentage. What's the probability that he didn't win the competition? We know he won. But if you wanted to, before the competition, you would have tried and work this out. What's the chance of me not winning? All right, let's go back up to the text here. There's the text. This winner was randomly selected. Mr. Sokutu won the grand prize of 150,000. He submitted 1,000 entries out of 10,000. Ah, Keon, you're too good. So he submitted 1,000 out of 10,000. All right. So he's got a 1,000 out of 10,000 chance of winning. Well, then what are the chances of not winning? Well, it's all the others. All right. So if there's 10,000 possibilities, that's definitely going at the bottom of our fraction. And he won with 1,000 entries. Okay. So the chance of him not winning, whoopsie, is all the other entries. All right. So 1,000, let me type it in here at the top. A 1,000 will get you a win. So what will you need to not win? It's everything else. So there's 10,000 possible. 1,000 will get the win. So all the rest will be not winning. So it's 9,000 out of 1,000. Okay. 9,000 out of, sorry, not 9,000 out of 1,000, 9,000 out of 10,000. So it's 9,000 out of 10,000. All right. Now we need this as a percentage. So you all know that we have to multiply this by 100. Well done, Keon. Very good. So that's 90%. Okay. 90%. So just remember at the bottom of the probability fraction, it's all the possibilities. In this case, are all the possibilities. And then the chance of him winning here was he got 1,000 out of 10,000. Right. So what's the chance that the people that didn't win? Well, there's 9,000 out of that 10,000 that didn't win. All right. So those are the losing entries.